Hey class, it's Professor Rourke here. Okay, I want to talk about a couple of the questions from the Chapter 6 review. It's a little confusing for some of us to keep everything straight, especially because Chapter 6.1 was all about discrete probability distributions, and then 6.2 was about binomial, and then the back and the forth. So let's take a look at this problem. For example, this is question 6 from the review. So it says, during a marketing setting, each of the 127 college students selected showroom displays for portable grills. 5 different displays representing 5 different size grills were available. The students were instructed to select only 3 displays of grill number 2, a smaller grill. The table that follows shows the grill display combinations and number of each selected by the 127 students. Suppose one of the 27 students is selected at random. Let X represent the sum of the grill numbers selected by that student. Complete parts A and B. Okay, so let's click this table. So this is saying the grill display combination 1, 2, 3 is 31 students. So what they're saying here is X is the sum of the grill numbers. So this grill display 1, 2, 3 actually corresponds to X equals 6, because 1 plus 2 plus 3 equals 6. Okay, so it's a very odd worded problem anyways, so that doesn't really help anything. But let's go ahead and open this up in StatCrunch. And we did one sort of similar example to this, but again, this is worded weird, number 1. And then also number 2, they don't give you the probability. They just give you this these grill displays, which again, I'm just going to go ahead and replace 1, 2, 3 with 6. And I'm going to replace 1, 2, 4, 7. And I'm going to replace 1, 2, 5 with 8. I'm going to replace 2, 3, 4. Oh, we didn't replace that. Go. 8, 9, 10, and 11. Okay, so that could be part of the issue on its own because it's confusing what they're talking about, these combinations and what the X is supposed to be the sum of the numbers there. Okay, so we did that. And then there's a couple ways you can find this actual amount here, this P of X. So you can do it quote by hand, where you add these up, right? And then you divide each one. I also sometimes just find it I'm kind of lazy sometimes. I don't know. And I like to just sometimes use a pie chart. So it tells me in percent. I do have to change it to decimal places, but sometimes I like to do that. So for instance, 6 is 24.41. So again, this is just me being lazy. It says round to the nearest thousandth. So that's 3 decimal places, right? So 10th, 100th, thousandth. So actually, let me take that back to 0.244. Okay, and then 7 would be 0.055. 8 is 37.8, so that'd be 0.378, and just moving the decimal place 2 times. But again, if you would like to if you'd prefer just to go through and add these up, add the frequencies up, and then just divide each one there, that works just as good. Okay, I had too many numbers here. Let me take that back. 0.016, and then last but not least, 0.268. Okay, so as long as I rounded everything correctly there, I'm just trying to look through and check that out. I think that looks good. Okay, so that is the tricky part about that is we have to go through and actually calculate those probabilities. And also, again, it's kind of confusing because the problem is crazy with these combinations. Okay, so then they say, what's the probability that X exceeds 10? Okay, so from here, what you want to do, and again, you don't have to, there's a few different ways to get to this part. We saw only one question sort of like this, where they didn't give you the probabilities. You had to first make the probability distribution table and then answer the questions about it. But again, not only do we have to do that, but it's worded very weird. Okay, so what I went ahead and did is I just entered in the probability distributions on this column here. Again, there's lots of different ways you can do this. I'm also going to go ahead and label this as P of X, but I don't forget, I'm going to label this as X since I changed that. Okay, and then I'm going to go to Stat, Calculators, Custom, select X and P of X, because that's why I sort of labeled them, just so I didn't really have to think much about it. Okay, so this is my mean, this is my standard deviation. And then I can also use this probability part down here. It says, what is the probability that X exceeds 10? So once again, we gotta kind of think through what that means. If it exceeds 10, it means they don't want 10. Okay, they want anything greater than 10. So for this problem, it's actually just whatever we have for 11. So I could just look here and say, oh, it's going to be 0.268. Or I could use these buttons here and say, I want X to be greater than 10. And it tells me it's 0.268, which again is just the 11th one there. So you can do that. Call it a day. Okay, so 7, that was again, 6 was tricky for a number of reasons, because first the wording was weird, and then we had to actually calculate this column for P of X. And then that was it. Okay, so then this one though is a little bit more straightforward, where they give you an X, they give you a P of X. Is this a probability distribution? And this little drop-down button is usually what they're looking for, because the probabilities are between 0 and 1 inclusive, and the sum, oops, sorry, clicked the wrong one, and the probabilities is 1. Okay, so that's good. And then it says draw a graph, so you could literally just try to my allergies are getting to me, so sorry. Let me take a little drink first. Okay, sorry. What I'm just going to go ahead and do is what we just did again, where we use stats, calculators, custom. We have X and we have P of X, and then match the graph up from there. Let me do a little screen halvesies. Okay, so we look through here and it looks like, you know, I believe sometimes you have to be careful because it is kind of hard to tell if they have the same shape. But it looks like this is the only graph that has the correct shape. This would be C, so I would just check that off. Again, sometimes you have to be a little bit more careful and maybe do like a pop out of the graph to take a look closer. And then they talk about what the distribution is. You'd say it has one mode because there's one that's the highest. There's not two that are the same height, like that are both the highest. And I think I would technically say it's skewed to the right because that is where the tail is. And then they want to know the mean. We already have that because this is the mean right here. So we'll go ahead and say do not round, 1.6258. And remember, again, that is the same thing as the expected value. So that is what they're talking about here. So it says over the course of many games, that's the key there about expected value. If you do it a lot of times, the mean would be the expected value, okay? So I'm just like looking through and making sure that that's the only one that sounds like that. Yeah, okay. And then standard deviation, we can do that. They give that to us here. That is the 1 point. They usually says 3 decimal places. Okay, I was going to say, sometimes they say 1 decimal place. Well, that's a lie. They did 3 decimal places here. So 1.176. We would have to bump that up. And then what is the probability that in a randomly selected game, the player got 2 hits? Okay, so you could technically use this stat crunch feature here, but if it's exactly 2 hits, we already have that probability. It's right there. Okay, it's 0.2863. Okay, and then what is the probability that the player got more than 1 hit? So we have to sort of think, okay, do we want to include the probability of 1? No, they only want more than 1. So that's the probability of 2, 3, 4, and 5. So if you're doing this by hand, you can just take these numbers and add these up, or you can go to StatCrunch and say we want it to be greater than 1, and get the same thing either way. It says again, do not round, 0.497, and that will be it. So I hope that helped a little bit. Again, 6 was a doozy because you weren't given the probabilities, so you had to calculate them. Plus, it was worded weird with this grill display combination. And they kind of sneak in there in the end that X has to be the sum of the grill numbers, but doesn't really make, I don't know, it just doesn't seem very intuitive. So they're really giving you like 6, 7, 8, 9, 10, 11, and then they're giving you the number of students. So we have to create essentially like a relative frequency table, which is what we started out with as the probability distribution. And then we can use that in StatCrunch we'll type those numbers in for its own column and then use that to calculate if they want the mean or anything like that. Okay. And then 7, they had the probability, but we had to go through that. So that is all the questions that are kind of the tricky ones in 6.1, the discrete probability, and then we get into the end there, the binomial probability distributions here. Okay, so let me know if you have any other questions about that in chapter 6. It did kind of step up, I feel like, in difficulty this week after chapter 5, just probability. And then we have chapter 7, which are kind of similar to what we did this week in terms of like difficulty 8 and 9. And those will all be together on the second test that we have coming up in April. Okay, I hope you have a nice break if I don't talk to you. And yeah, let me know how I can help.